Hey guys, so this will be the chapter 3 review for all the questions on here. I know that one of the questions, the older packet contains some question that was actually not from this. So please ignore that, and because I cannot verify the answers for you regarding that. What we're gonna do is we're just gonna go over all the new ones and all the answers with these, and hopefully this will be a good study material for you guys tonight for the multiple choice tomorrow. So which of the following relationship would you expect to have a negative association here? So negative association means as one increases, the other one decreases. We did this a long time ago together, but GPA and height, just read that over and think about, do they have any association? Do they have any relationships with each other? I don't think so. Number of chores in the weekly allowance. The more you do, the more you get for allowance, right? So that's positive association. Number of hours spent studying and test grade. Again, another positive association. Generally speaking, more you study, the better your scores will be. The number of miles driven and the amount of gas remaining in the tank. So as you drive more, the amount of gas will go down. So it's D. Age and IQ. As age increases, it's not generally accepted that the IQ necessarily decrease. I mean, some people can maintain their IQ for a significant amount of time. So this is not going to be the correct answer here. So the correct answer here should obviously be D for this one. Slope. Don't forget RSY over SX. So I'm just going to simply say 0.64 times 0.5 over 1.2. Just type that into your calculator and that should be pretty much it. So here I'm just going to go to 0.64 times 0.5 divided by 1.2, and bam, I get 0.267. So I eliminate these guys. They give me a point X and Y as 3.8 comma 2.7. So only one of these should work. 1.687 plus 0.267 times 3.8. I'm just going to use answer choice C. Oh, hey, look at that. It does give me 2.7. Obviously, D is obviously not going to work out. If you plug in the point, it doesn't work out. All right, next question. Whoa. It says R is negative 0.83. What can you conclude about two sets of the data? Well, it's negative. It's strong. Let's just keep that in mind for now. Both data display a strong linear association. Okay, so that seems to be fine, but a strong linear association with this type of correlation coefficient, we definitely want to say that 0.83, as long as it's higher than that, I mean 0.0 higher than 0.8, we want to say that it's a strong, but it's a linear association. But the problem is that you can still have a nonlinear relationship and still try to somehow formulate the best line of fit, and it can still give you a very high R score with that. So the problem here is the word linear. The linear word is not going to be appropriate because you don't know if it's going to be nonlinear or not. So that's not enough information for us to say A. 0.83 does not have anything to do with 83% of something. Okay, you talk about percentages when we're talking about R squared, however. Okay, Meg's data is more linear. No, it just means because they have the same R value doesn't mean that one is more linear than the other. So nothing can be concluded. That should be the correct answer here. Okay. All right, number 4, given the following Minitab printout, so we have these two to worry about and probably this. Since 80% of variability of the Y explained by the linear association created with X, this is absolutely true. So it's not a false. Since R is equal to that, is that true? Let's check it out. So we want to, let's bring the calculator. Square root of the R squared value, which is 0.8, gives you 0.894. So I believe R value should be 0.894 though. The linear association between X and Y is strong and positive, but I do not like the number here for some reason. So I will just leave it blank for now. As X increases by 1 unit, Y decreases on average. Okay, that's perfectly true because that's the slope. When X is 0 units, Y is predicted to be negative 0.868. That is the Y-intercept, so that's true. The equation of LSRL line is that. Okay, so the only answer is B. I think I forgot one thing. R can be negative. And it should be negative because your slope is negative. I completely forgot to look at that. So since R is 0.898, I don't like it because it should say 4. But also at the same time, R should say negative 0.898. Because the slope is negative, it means that the line is going down. Your correlation coefficient should also be a negative number. All right, which of the following scatter plot could have created with the following residual plot? So that's the residual. Please take a note that these two dots down here, they actually fall below the line. Then the middle, the dots are actually above the line. Then it goes down to having the dots below the line. So draw the best line of fit for all of these things. I mean, I'm doing the best that I can for these, but so something may look something like this. Okay, so those are your best line of fit. And now you want to eliminate A and D right away, particularly because you have just dots happening just all over the place. So in the very beginning, you see that these two dots are actually like kind of like on the money, like the first dot is on the line, but the first dot has to have the biggest decrease in the residuals. Same thing for this one. I mean, these dots are like in the middle, we have even like positive, negative residuals. So we can't have that. So which of the following gives you the highest, lowest possible point for the very first point? And it's got to be below the line. This is above the line, so I can't have C. This is also above the line, so I can't have E. Notice how in the very first point, the residuals is longer than this residual would be. Then all of these dots in the middle have a positive residual. Then it goes down to like, I mean, the line is obviously not a computerized, so it's not correct, but B is the correct answer for this because of that reason. Okay. All right, number 6, which of the following is correct interpretation of the slope of LSR? So I have no choice but to use my calculator for this one. So go to stat, edit. I'm just going to clear this list. 0, 5, 6, 7, 8, 9, 10, 11, 12. And so this would be 7.5, 49.8, 58.2, 65.9, 76.8, 88, 88.2, 98, 98, 108.2, 116.9. All right, so stat calc 4. Let's press enter. Bam. All right, so that means 9.24 y hat plus 4.5x. So that's my best line of fit, least squares regression line. So this is talking about the y-intercept at year 0. So at year 0, the number of students that I should have should be 9.247, even though this is the actual. This is the predicted amount at that particular time. So we're talking about the slope. The slope is 4.5. Okay, just by knowing that, I can eliminate A, B, and C because they're all talking about the y-intercept. It has to be for each consecutive year, an average of 4,500 students will take AP stats exam. So as the year increases by 1, in thousands, the number of students will be increased by 4,500. So yes, 6 should be D. Or wait a minute, did I make a mistake on this one? Let's see. Oh, I'm sorry. A should be your slope. Oh, that's my fault. Yeah, sorry. I got my equation incorrectly. All right, so that should be X right here plus 4.5. So that means this is your y-intercept. So I have to completely loop back around this. All right, so that means I have to eliminate the one that actually contains 4.5. So A's and D's are out. So amongst A, B, and C, yeah, so every consecutive year, 9,250 more students. Every year, 9,250 students, more students to take the AP exam. So if you're really contemplating between B and C like this, you want to pick the one that actually gives you the more cushioning words. So again, I just mentioned these cushion things to kind of indicate the fact that like the least squares regression line always allows you to predict something. It doesn't actually give you the actual number. C says every year, 9,250 more students will take the AP exam. So it's kind of like straight up telling you every year we can expect 9,250, period. No questions asked about it. B is saying for each consecutive year, same thing as every year, an average of 9,250 more students take the AP statistics exam. The word average means that it doesn't necessarily have to be 9,050 students more each time of the year. Rather, when you take the overall sum of every increase out there per year, divide by the number of years, by average wise, we can expect to be around 9,250. So B is the correct answer between B and C because of that reason. Okay. Which is the following correct interpretation of the intercept? Okay, so now we're talking about the 4.5, I mean. The first AP statistics exam had 4,500 students taking it. The first AP students exam is predicted to have 4,500 students taking it. So all the other ones is complete just trash, right? We don't really want to think about that. So what do we want to pick? We want to pick the one that allows you to predict, because correct interpretation of the LSR, least squares regression line, that's always a prediction. So that correct answer here would be C. Okay. B is just straight up telling you. Okay. So that's why we don't always want to pick, we don't want to pick the one that always just straight up tells you something that's going to be this, like cause and effect relationship. We never want to say cause and effect in chapter 3. We all, like in statistics in general, we don't want to say cause and effect, because we always study the relationships, and then we always say that's going to be likely, tend to, we can predict what's going to happen. Doesn't mean that you're going to be right? We can predict approximately what's going to happen. So 7 is C. Which of the following is the correct interpretation of the coefficient of determination? Oh boy, I did not turn my diagnostic on, so I did not get that information. So second 0, x to -1. So I'm just going to go straight to the diagnostic on right here, turn it on, stat, calc, do this one more time, and bam, R squared is 0.996. So we're looking at 99.6% of the variability in the number of students. The number of students is the Y value. So we definitely want to eliminate all of these answers. I know the C is repeated, so we want to eliminate both of the C's as well as D, because explained by the linear relationship with the number of students. So variability in the number of students. Always want to talk about the response variable first. Taking the AB stats exam explained by the linear relationship with the year. Oh, wait a minute. That the R squared value was 8%. No, I'm sorry, 99.6%. So the correct answer here should be B for this one, for 8. Sorry about that. So that should not be, yeah, so 99.8% makes no sense, because that's not the value that I got. Very close, but 99.6 is the one we want to go for. 9, what a set of data has a residual plot, which of the following is true? Right, so here, this is actually quite ambiguous, and I wish that there was some sort of explanation as for this one. But the correct answer here, let's go over one thing at a time. A linear model is not appropriate model for the data. We should all know this is true, because we see a trend, we see a pattern. So 1 is definitely true. This we're going to eliminate right away. The data shows an exponential trend. The reason for this that it's not going to be true is that if I were to translate this into some sort of a scatter plot, let's say, where in the beginning I have a very high residual, I have a very high residual, but in the middle I have very small residuals, and then it's slow, and it comes to like some sort of a stop, right? So let's say that I have, it says that it contains an exponential trend for some reason. But I want to show you guys that even with a positive slope, just to prove that the 3 is actually, also one of those things that can happen. So positive slope means that I can have dots that's below the line like this. And also, there's a couple points right here that's positive. And so like, it could look something like this. It could look like a Nike swoosh for all I care in the, in this kind of data set. But let's say that this is the type of data that we're looking at, okay? Where in the beginning, you have a very high positive residuals clearly indicated by here, but then you have all of these low negative residuals that's indicated by here, okay? So if you take a look at these values here, you can see that there's going to be like this, some sort of like a positive trend. It's definitely not a negative slope. It doesn't always necessarily have to have this negative slope. So 3 is definitely going to be out of the equation. So D and E contains a 3. So the only answer here is just going to be A, which means part 2 should also be incorrect. And that's true, because if I eliminate all of these dots, like you look at this and go, okay, can you explain how this has an exponential model? This is more clearly towards a linear trend if I ever saw one, right? It's a linear trend. You can design it so that it could be possibly exponential, but it doesn't necessarily have to be that. Judging from the you're only looking at the residual plot, it's impossible for us to determine that. So yes, the biggest idea is for you to be able to draw the scatter plot based on the residual plot. But if that's too difficult, always note that from the residual plot, we can't really determine it. There's just too many factors that's involved that it could potentially create a linear trend. Who knows? It could be exponential, but I just drawn you an example of a linear trend that's a positive slope. So one is definitely true. Even though a linear model is not appropriate for the data, it's not appropriate, but doesn't mean that it can't have that trend. It could show that relationship, but that's why one is definitely true, because we talked about the scatteredness of the residual plot. It doesn't show you that. So one is true. The other ones, you can't have it. Which of the following scatter plot displays data with the correlation coefficient of 0? Okay, so first of all, that's positive, positive, negative. So let's eliminate A, C, and D. Between B and E, farthest. Oh, I'm sorry, I did not read that word. Farthest from 0. My fault. Farthest from 0 basically means which one ever shows you the strongest correlation, close to 1 or positive 1, right? Because that's the farthest values away from 0. I really like D. These are all scattered over here. These are scattered more, so the correct answer is D. B and E obviously makes no sense because those two are the weakest correlations. So 10 should be D, yes. Number 11. Some of you guys asked me a question about this, but quite honestly, if I'm asked to find out which of the 5 predictors should the realtor choose, you want to pick the one that actually gives you the highest R value. That doesn't necessarily have to be positive or negative. It's as long as it's farthest away from 0, it's whichever is closest to being 1 or negative 1. The more it's closer to 1 or negative 1, the more relationship that it shows. So it's got to be A, because it's 4, 6. Compared to all these other numbers, 4, 6 is the highest number. Number 12, we have R squared is 0.25, which of the following is a correct statement? That means 25% of the variability can be explained in the car price. The response variable can be accounted for, can be explained by the LSRL with the explanatory variable, or with the explanatory variable and the response variable. You can put those two together, but obviously we understand that it's E. You follow the template. That's what R squared is all about. Number 13, consider this following. Okay, so this one was really easy. You just kind of draw like best line of fit for these three. This is very strong. This is moderate. And this is like weak, like it's super duper weak. So it's from the smallest to largest should be 1, 2 to 3. So it should be A for 13. Consider the following, for which the scatter plot is the standard deviation of the least square. Okay, so standard deviation about the least squares regression line means that the R value is very, very small. Oh, I'm sorry, not the R. Your residuals are very, very small. So the residuals are small means that the line and the dot falls perfectly well with each other. This one, okay, I'm just going to eliminate this because it makes no sense. This is very weak. This is also very weak. So between B and C, which one's stronger? Obviously B. So if the line and the dots are very close to each other, your residuals are very small. Therefore, your standard deviation of all the least squares regression line of the residuals will vary very in a small detail. Like, so it's going to be very small. In other words, it's going to be B because the residuals are smallest, or the line fits the dots very well. So the answer for 14 should be B. Great. All right, so the next question, we want to use this equation right here. So you plug in 82 into this, and this is your actual. Remember, if I want to find out the residual, it's always actual minus the predicted. So I'm going to go to my calculator here. So 0.01489 times 82 plus 4.108. That's 5.32898, but the actual is 4.5. So you have to do 4.5 minus that answer gives you negative 0.828. So which means that the residual is around this, somewhere between -1 to -5. And that's all there is to it for 15. 16, which is not true of R. R is independent of units of Y and X. That's actually very true. Even if you swap the X's and Y's, your R value doesn't get impacted. Like I said before in the previous videos, it's very resistant. The only time it's actually going to change is if you take the values of X and Y and multiply by -1s for one of them, then it's going to like flip it over, which makes from negative correlation to a positive correlation. That's the only time it's going to change. R is between, nope, it's always going to be between -1 to 1. So I think I found my answer already. It's B. R measures the strength of the linear relation between X and Y. Absolutely true. R does not depend on which two variables is labeled as X. Like I said, that's very closely related to S choice A. R is less than 1 unless the points in the scatter plot points up. Exactly true. So it's going to be B for this one. All right, 17 and 18. So we have the equation based on this. So by looking at that, I'm eliminating A, B, and C right away. That's your slope. That's your y-intercept. So it should be D. Oh, that was easy. Obviously I'm missing a hat. I don't like that. You should have a hat over the predicted manatees. The estimated standard deviation of the residuals, it's right here. All right, that's no brainer. So 19 through 20, the data was used to produce the following regression output, which is the value of the correlation coefficient. So you take that and you have to square root it. But you always have to make sure, pay close attention to the slope when you're doing this, because sometimes it's very easy for you to forget. Square root of 0.369 gives you 0.607. So that means that your R value is 0.607 or R is negative 0.607. It could be negative or positive in both ways. Because the slope is negative, it means your linear trend is going downwards. So it's B for this one. Yep. What proportion of variability in salary can be explained by the linear relationship? Can be explained variability, linear relationship, response variable, and the I'm sorry, this is your explanatory, this is your response. That's your R squared all the time. Like it's just gotta click now. Okay. That's 0.369. Two variables, X and Y. So this is the most recent thing that I talked to you about of how you can change your X and Y, apply the changes and to achieve linearity. So here we have the regression plot. I'm sorry, residual plots, my mistake, which is the following conclusion is correct. So when we actually do the X versus log Y versus log X versus log Y, it turns out that the model A is not great for linear measurement because you see this curved pattern here. Whereas this is the randomness and the scatter that we actually want to have in the residual plot. So model B is definitely the one that's appropriate. So I want to eliminate always the one that doesn't contain model B is appropriate. Since the relationship between X and Y is linear, between X and log Y is linear. Log Y is the one that we want to use. So the answer is E for number 21. All right. Like I said again, the reason why it's log Y is because look at the equation up here. It's not X versus Y, it's X versus log Y. So just follow along with the context and just put down the answer. Number 22, two measures of X and Y. So this is residuals. We have the least squares regression line. The second one gives me this. So obviously you see this little curved pattern here. This one also kind of goes like this. So basically at the end of the day, we want to pick the one that's a better fit for either one of those two, because it doesn't say, quite honestly, like okay, well, technically speaking, I shouldn't say that because it does show a little bit more randomness here compared to this. That's for sure. There is a linear relationship between X and Y. For this one, no, clearly not. So X and Y, we don't want to say regression 1 is the better fit. So regression 2 should be a better fit. So we want to say either B or E for this one. And C makes no sense because you can't tell a negative correlation. Like I said, from a residual plot, we really can't determine that. There's too many ifs, what ifs factors that really dictates as to how the scatter plot is going to go. And it's really hard to determine that. It could be positive association for all I care. There's a linear relationship between X and Y. There's a non-linear relationship between X and Y, and regression 2 yields a better fit. Between X and Y, yes, there's a non-linear relationship. How do I know that? Because when I plotted a residual plot between just straight up X and Y with this equation, it shows me a pattern. So there's a nonlinear relationship when we're comparing X and Y. There's a linear relationship between log X and log Y, because if you take a look at this, log Y and log X, it gives me much more randomness and scatters in the residual plot. So there's a linear relationship when we actually compare these two, but it's X and Y only, then it's nonlinear. And regression 2 obviously yields better results. So the answer here is going to be E for this one. All right, so we're down to the last 3 or 4 free response questions. Find the equation of LSRL. So this, it gives me the data plots right here. So we're just going to use that and then just type it all away. All right, so using the calculator, so 0.31, so that should be flow rate. We want to compare the flow rates and the weight. Okay, so 0.31, 0.85, 1.26, 2.47, 3.75. And then list 2 would be 0.82, 1.95, 2.18, 3.01, and 6.07. Stat, calc, 4, bam, 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 bam. All right, so I have the equation here. We have y hat is equal to 1.389x plus 0.405. So that should be your least squares regression line equation. So where if you wanted to be a little bit more specific with the variables, we can simply say that the y is the amount of eroded soil. So this should be your flow. So amount of eroded soil should always be your X here. Oh, I'm sorry. No, that's not true. This is not your computer data. I'm sorry. So your X should be your flow rate. And this is your amount of soil, eroded soil to be exact. Interpret the slope and the y-intercept in the context of slope. For every one, what is this? In liters per second. And this is in kilograms. For every one increase in flow rate in unit of liters per second, the amount of eroded soil increase by 1.389, was it kilograms? Yeah, kilograms. So for every one increase in the explanatory variable, the response variable increases by the slope. That's basically what it comes down to. The y-intercept. The y-intercept basically means when the amount of eroded soil is, the soil is at 0. I'm sorry, not the soil. The flow is at 0. The amount of flow rate, liters per second is 0. The amount of eroded soil. Sorry, I'm really writing this super quickly, so my handwriting is terrible at the moment. But the 0.405 kilograms represents when the flow rate is at 0. So that's what this number is for. Or your initial amount of eroded soil, if you want to say it like that. Give the value of the correlation coefficient interpreted in the context. Okay, so that comes from this. My R value is 0.9669 and correlation coefficient determination is R squared, so 0.935. So you guys all should know, interpret this in the context. This demonstrates that the level of association between these two, flow rate versus amount of eroded soil, is positive, strong, okay? And it shows that there's going to be a linear trend, okay? I mean, I can obviously kind of go a little bit further ahead and go to second plot and turn this one into a scatter plot with this. And you can see that this is a linear trend just by looking at those 5 dots. So again, direction, strength, as well as form. Coefficient determination, 93.5% of the variability in the response variable, which in this case will be your eroded soil, can be accounted for, can be explained by blah, 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 LSRL with the explanatory variable in this case, which is the flow rate. I'm going to skip over that part. You do the rest. Calculate and interpret the residual flow for the rate of 3.75. So we're going to use our equations to our benefit. Y hat equals 1.389 X plus 0.405. I'm just going to plug that into right there. So let me go to my calculator. So let's say I do 1.389 times 3.75 plus 0.405. Bam, 5.61375. That should be your amount of the amount of eroded soil. But for 3.75, we actually have the amount of eroded soil. This is the actual amount, which is at 6.07. So it's 6.07 minus the 5.61375, which should give you, so 6.07 minus that answer that we just got. So the residual would be 0.456. 0.456. The answer key says 0.45, but again, just leaving a little bit more decimal points just to indicate that. All right, 24. So I have all these wonderful things. Residual shows me that there's some sort of a pattern here for this as well. So the linear model is not a good fit. Give the equation of LSR, predicting the guess number of gumballs. So that's a slope. Oh, sorry, that's not, there shouldn't be a hat there. Times gumballs. Plus 28.52 gives you the actual number of, predicted gumballs. Or guessed gumballs. So this is actual. Comment on the appropriateness of the linear model for this data. The linear model is not appropriate. So least squares, linear model is not appropriate. Because we've talked about this, as the actual number increases, the residual gap, they actually decrease and increase by the same amount. So it kind of shows like this sort of trend, which is still a pattern, because there is clearly a pattern in the residual plot. So I'm just going to abbreviate it. So therefore, the linear model is not going to be a good fit. So the answer key also said the residual plot does not show a pattern. So a linear model is an appropriate model, it says. I don't agree with that at all. For this one, there's definitely, if you see this type of thing where in the beginning it's like that, you can go back to chapter, I think it was 3.2 with the residual plots. If you actually see a trend that looks like that, it's not going to be a good fit. I can go into the textbooks one more time, but the answer key for this is actually not going to be correct. All right, moving on. So 25, we have, again, residuals. Now, this is much more like it. There's a randomness there. Circle the unusual point in the scatter plot, obviously this one, and the residual plot, which is this. If this point was removed, describe the effect of the correlation. So if this point was removed, again, there's a large residual for that. Your correlation, therefore, will actually increase because now your line will tilt this way, and it's going to be a much better fit with all of these dots being very closer to the line than, having to deal with that line from the get-go. And the least squares regression line will have a higher, that will have a lower slope, because you can see how it was flattened out like this. Well, it's technically going to have a negative slope, but it's going to have a greater negative slope. Yeah, so it's going to be more tilted in the negative direction. So it's going to have a higher magnitude of slope, but then it's going to have a negative direction. So correlation will definitely increase. How would you classify this point? High leverage. And this is definitely influential because it definitely creates that tilt, creates that change in the slope. It's also it's an outlier because it has a very high residual between the line to the predicted to the dot. So it's an outlier, influential, and it has a high leverage. Looking at the answer key here, the upper right, the correlation coefficient will get stronger, the slope will decrease, and the y-intercept would also increase. So y-intercept was at 250, but now it's going to be around like 300-ish or so, and it's an outlier, influential. And it says that we would need more statistics to tell for the answer key, but I would definitely say it's an influential because it changed y-intercept, slope, and the correlation coefficient. That's good enough to say it's influential. And also, this is a new thing that we talked about for 3.3, which is high leverage. That will be another thing that I would like for you guys to say. 26. Here's a linear regression output of the three models. Okay, so this first one measures the x versus y, log x versus log y, log x. No, I'm sorry. This is your y here, log y versus your x, because precedent number is your x. So that's your explanatory variable. So that's your log y versus log x. And then the first one is obviously just your y versus x. Okay, so with that in mind, which model does the best job of summarizing the relationship? First of all, you want to look at the residual plot and this value. Look at the residual plots and the R squared value, and you want to pick the one, number one, gives you the highest R squared value as possible. Number two, no pattern in the residual plot. There should be scatters. I see a pattern for this. There's a little curve. There's a little curve. As long as you see that little curve there, we don't want to use that. This is clearly much more randomized. It's much more scattered. But not only that, I mean, just take a look at the R squared value. It's 0.766. So what we want to say is definitely model 3 because of those two reasons. Number one, highest R squared value of 0.766 for this one. And then the residual plot shows scatters or much more scattered compared to the other two. Use the model chosen in part to calculate and interpret the residual for the 45th president, Donald Trump, whose State and Union address contained 1.73% America. All right, so the equation for this one, we want to say it's these two numbers basically. So the slope is 0.0315, x representing the percent of the president number. The constant is minus 1.4325. And so that will be your y hat. Now the y hat represents the percent America, and this is the president number. But there's one thing that we need to keep in count of. This is log of y. So when we actually make the equation, we want to say log of y hat is equal to this equation. So at the end, we want to pick the 45th president. So we're going to put the 45 in there. So if I use this equation, I'm going to put a negative 1.4325 plus 0.0315 times 45th president. That becomes negative 0.015. So log of y hat is equal to that. Remember, you want to convert this always into your exponential form. The base is 10. So this is something that I'm not going to teach you, but if you want to convert from logarithmic form to an exponential form, you take the base number, raised to the output of negative 0.015. That should be your output, which is your y hat. So 10 raised to that power should give you y hat to be 0.966, about-ish. So that is 0.96% America after I calculate it. So then we are trying to find out the residual. So residual is always your actual minus the predicted. So y minus y hat. That's equal to 1.73% minus 0.966. So using the calculator one more time, 1.73 minus the answer, you should get 0.76. That, or 3. Technically, that's correct answer for your 26 part B. Okay, so that summarizes your test 3, or I mean, sorry, your review chapter 3. Hope this video helped, and I'll see you guys tomorrow.